Good day, everyone. I am Eliza Sicurata, Best in Math 1A, reporter for the topic Life and Works of Gauss, Klein, Legendre, Monte, Proncelet, Cauchy&Cantor. Carl Friedrich Gauss. Johann Carl Friedrich Gauss was a German mathematician and physical scientist. He contributed significantly to many fields, including number theory, algebra, statistics, analysis, differential geometry, geodesy, geophysics, electrostatics, astronomy, and optics. He is often referred as the prince of mathematicians as well as greatest mathematician since antiquity. Gauss exhibited genius from a very early age. When he was only 3 years old, he corrected an error in his father's spiral calculation for his laborers. When he was 10 years old, he dazzled his school teachers by quickly summing up the integers from 1 to 100. Gauss realized that if the numbers were paired up of 1 and 100, 2 and 99, 3 and 98, 4 and 97, and so on, each pair would always sum up to 101, and there are 50 such pairs, so the sum would be summation of 50 times 101 is equivalent to 5050. Then in 1901, at 24 years of age, he published his book Disquisitiones Arithmetica, or known as Investigation in Arithmetic, which is regarded today as one of the most influential mathematics books ever written, and which laid the foundation for modern number theory. The book contained a clear presentation of Gauss' method of modular arithmetic, and the first proof of the law of quadratic reciprocity, first conjectured by Euler and Legendre. Aside from the contribution I'd mentioned earlier, Gauss has many more remarkable in many fields of mathematics and science. Unfortunately, it will be a long discussion if I'm going to discuss each of them. Felix Klein. Christian Felix Klein was a German mathematician and mathematics education, known for his work in group theory, complex analysis, non-Euclidean geometry, and on the connections between geometry and group theory. 1866, he was appointed to the post of laboratory assistant to Plucker. 1872, Klein was appointed professor at Erlangen in Bavaria in southern Germany when he was only 23 years old. During 1882, his health collapsed. During 1883 to 1884, he was plagued by depression. 1886, Klein accepted a professorship at the University of Göttingen. Klein established a small team of editors who met regularly and made democratic decisions. The journal specialized complex analysis and algebraic geometry and invariant theory. During his time at Göttingen in 1871, Klein made a major discoveries regarding geometry. He published 2 papers on the so-called non-Euclidean geometry showing that Euclidean and non-Euclidean geometries could be considered metric spaces determined by a Cayley-Kim metric. He died in Göttingen during 1925. Adrien-Marie Legendre was a French mathematician who made numerous contributions to mathematics. Well-known and important concepts such as the Legendre polynomials and Legendre transformation are named after him. Legendre transformations. The Legendre transformation is an application of the duality relationship between points and lines. The functional Gaspard Monge was a French mathematician. The invention of descriptive geometry, the mathematical basis technical drawing, and the father of differential geometry. Gaspard Monge is considered the father of differential geometry because of his work application de analyse à la geometrie, where he introduced the concept of lines of curvature of a surface in 3 space. He was educated at the College of the Oratorian at Beno. 1762, he went to the College della Trinity at Leiden. 17 years of age, Monte was put in charge of teaching a course in physics. 1764, he returned to Beno. The plan to Beno that Monte constructed was to have a major influence in the direction that his career took. For the plan was seen by a member of staff at the École Royale d'Eugénie at Miseres. He was very impressed by Monte's work, and in 1765, Monte was appointed to the École Royale d'Eugénie as a draftsman. About a year after becoming a draftsman, Monte was given a task which allowed him to use his mathematical skill to attack the task he was given. Asked to draw up fortification plan which prevented an enemy from either seeing or firing at a military position, no matter what the position of the enemy. Monte devised his own graphical method to construct such fortification rather than use the complicated methods then available. This method made full use of the geometrical techniques which Monte was developing in his own time. His mathematical abilities were now recognized at the École Royale d'Eugénie, and it was realized that Monte was someone with exceptional abilities in both theoretical and practical subjects. Between 1770 and 1790, Monte contributed various papers on mathematics and physics to the Memoirs of the Academy of Turin, the Memoires des Savantes Strangers of the Academy of Paris, Annales de Chimie, sur la théorie des déblais et des remblais. Monte was an atheist. Monte died in Paris on July 20, 1818. Jean-Victor Proncelet, French mathematician and engineer who was one of the founders of the modern geometry. As a lieutenant of engineers in 1812, he was badly wounded during the Russian campaign and left behind at Krasnoy, where he was thought to be dead. He was taken prisoner and remained at the camp of Serato until 1840. He published Traité des Prêtres Projectives des Figures in 1822. Projective geometry. Mathematics that deals with the relationships between geometric figures and the images, or mapping that results from projecting them onto another surfaces. 1825, he became the professor of mechanics at the École d'Application in Metz, a position he held until 1835. In 1841, he became a lieutenant colonel, then 3 years later became colonel, and on April 19, 1848, a general of brigade. In April 1848, he also became director of the École Polytechnique. He died on December 22, 1867, in Paris without the recognition he deserved for his brilliant contribution to the world of numbers. Augustin Louis Cauchy, French mathematician in analysis and the theory of subtraction groups, group whose elements are ordered sequences of a set of things. He was one of the greatest of modern mathematicians. Cauchy became a military engineer and in 1810 went to Cherbourg to work on the harbours and fortification for Napoleon's English invasion fleet. 1813, Cauchy returned to Paris, wherein Linguère and Laplace persuaded him to devote himself entirely to mathematics. The following year, he published the Memoir on definite integrals that became the basis of the theory of complex functions. Then in 1816, he held professorships in the Faculty of Science, the Collège de France, and the École Polytechnique, all in Paris. The three greatest contributions of Cauchy in mathematics: first, courses on analysis from the École Royale Polytechnique in 1821; second, resume of lessons in infinitesimal calculus in 1823; and the last one, lessons on the application of infinitesimal calculus to geometry in 1826 to 1828. Cauchy&Cantor, a German mathematician who founded set theory and introduced the mathematically meaningful concept of transfinite numbers, indefinitely large but distinct from one another. Set theory. In 19th century, he founded and started to develop the mathematical theory of sets, which aims to investigate well-defined collection of objects. Transfinite numbers. In 1915, Cantor demonstrated that these numbers are infinite, which are larger than all finite numbers, yet they are not necessarily absolutely infinite and are called transfinite numbers. These also include the transfinite ordinals numbers, used to provide an ordering to infinite sets, and the transfinite cardinals numbers, used to qualify the size of infinite sets. Continuum hypothesis. In 1878, the continuum was proposed and originally formulated by Cantor, which state that an infinite set with a cardinal number between a small infinite set of integers and all infinitely large set of real numbers does not exist. Cantor's diagonal argument. Diagonal argument, or also called as Cantor diagonal method. It is a mathematical argument to show that if a given set is a set of integers, real or any natural numbers, then it cannot be used in one-to-one correspondence, meaning it's an argument to prove that a set of real numbers is uncountable.